In this section, we're going to look at some physics algebra and just some basic rearranging. I'll have a section later on where I go through every single equation and every single way you could possibly rearrange it. But here's just a little practice. So here I'm trying to solve for x. And so I look at the equation. I have v equals x over t. And a lot of students do kind of look at this and they're like, oh, it's on the right side. That just doesn't seem right. But it's not right versus left that you should concern yourself with. It's whether it's in the numerator, which is the top, or the denominator, which is in the bottom. If it's in the numerator, it's actually where you want it to be, and you just want to get rid of everything else. But if it happened to be in the denominator, which is like here, t, which is not this, and in this case we're looking for x, but if we're trying to find t, and let's say we got rid of x and got it over here, well, there's still a 1 in its place, and that physically, if I can't solve for t, it's not that it's on the right, but the t is on the bottom that's the problem. So let me just redo this, and I just want to kind of go at this example. If I say a dozen equals 12, or 12 equals a dozen, either one of those is a correct statement. But if I had dozen equals 1 over 12, that is incorrect, so that would be a problem. So it's not whether it's on the right or the left, it's whether it's in the numerator or denominator. And just another thing to remind you about, if I have the equation v equals x over t, v is the same as saying v over 1, so that's in the numerator. It's just a habit that we don't put that 1 there. We just, anytime it's just v equals x over t or v over 1 equals x over t, we just ignore that and we leave it off, and we start with v equals x over t. Okay, so now that being said, we're trying to solve for x. We need to get rid of t. We multiply t out by both sides. That gets rid of t, and we get x equals tv, or tv equals x, but I don't really like to see it that way. Once again, it doesn't matter. Mathematically, it's correct, but I like to rewrite it x equals vt or tv. Either one would be correct. This is just by habit. I like to see it this way. But tv equals x would work too. Either one is correct. That's the rearranged version for x. Okay, now here's when we had to solve for t, v equals x over t, we need to take additional step. We can't just get rid of x because that leaves 1 over t. What we need to do is we need to multiply both sides by t. And it gets rid of t. So we actually take a step and we get rid of t from that side, and essentially it's going to bring t to the top of the other side. So we have tv equals x, but now we want to get rid of v, so we're going to divide out v. When we divide out v, we have t equals x over v. Now just a quick way to think about this is that v equals x over t, I'm going to write this down twice, v equals x over t. If we are trying to solve for x, all we do is take that t and move it to the top. Remember, v is the same as v over 1. So if I move it to that side, I'm really moving it to the top. So x equals v times t. X equals v times t. Or if I want to go ahead and solve for t, I need to move t to the other side, which brings it to the top. But then I want to divide out v. So essentially what I did, all this math over here, essentially what I did was just switch this out. If it's in the denominator and there's nothing, be careful if there's anything added or subtracted, you got to do some other math first. Your answer here for t equals x over v. Okay, now this question, if I'm solving for initial velocity and I start off with x equals vit plus 1/2 at squared, x equals vit plus 1/2 at squared. Notice how I'm writing this over and over even though it's up top. It's a good idea just to get used to the equations. Some of you are, our class at my school, we give you an equation sheet with these equations, but just in case, it's just good to get used to these equations. And I'm trying to solve for vit. So I'm trying to solve something right here. In order to do that, I need to get rid of anything added or subtracted first. So I'm going to subtract 1/2 at squared from both sides. Minus 1/2 at squared. At that point in time, I have x equals 1/2 at squared. Sorry, I had a mistake. X minus 1/2 at squared on that side equals, and this cancels out, vit. So x minus 1/2 at squared equals vit. And now I'm trying to solve for and isolate vi alone. Now I can go ahead and divide out the t. When I divide out the t, this cancels out. So I finally get VI equals x minus 1/2 AT squared over T, and that's the answer. Here's an equation that we see a little later on in the semester. If I'm trying to solve for M1, I have Fg equals capital G, which is the universal gravity constant. You'll see that later on. Two masses, mass 1, mass 2, and a d squared. So I'm trying to isolate this one. Everything's multiplied or divided, so I can go ahead straight off the bat, multiply both sides by d squared. When I do that, I get this. At that point in time, I'm trying to isolate the M1 and the M1 from this G and this M2. Well, I can go ahead and divide out G and M2. Divide out G and M2. I'm doing the same thing to both sides. That gets rid of the G, that gets rid of the M2, and I'm done. M1 equals, once again, I like to see it this way, d squared Fg, force of gravity, over universal gravity constant times M2. And I like to put a parentheses around here because if I'm doing the math, a lot of times you can easily make a calculator error and not keep these two both in the denominator. Even though you don't think it's doing a certain thing, calculator will follow the order of operations. So it's important to have parentheses or use special tricks when you do the math here. Solve for equation above for D. Okay, so if I'm solving for D, Fg equals G, or capital G, M1, M2 over D squared. Solving for D, I'm going to go ahead and multiply out. Once again, it's in the denominator, so I don't want to keep it there. I'm going to take that extra step, and I'm going to multiply out D squared. I can't multiply, I'm multiplying both of them, the D times D, which is D squared, and that takes D up here. D squared equals, or D squared times Fg. And at that point in time, D squared's on the top. Now I want to get rid of Fg. So the next step is I'm going to divide out force of gravity, Fg. That divides out. And then last thing I'm going to do is take the square roots of both sides. So my final answer is G, capital G, M1, M2 over Fg. And that's how we do the math there. And that's it for this lesson.